Hey everyone, in today's video we're going to be going over the graph of the secant function and the cosecant function. I have pictures of the parent functions here at the top of the page, and as you can see they are extremely similar. They follow the same shape and pattern, where it has a parabola pointing upwards then a parabola pointing downwards. The main difference between the two is that secant is symmetrical over the y-axis, so it is an even function, and cosecant is not. So let's take a closer look at secant. So anytime we have a secant function, we are following this format, and each letter here represents a different transformation. So the letter A will let you know how far away from the midline that each of these shapes is. So whether it's downwards like I just drew, or it could be upwards this way. Okay, B will affect the period of the graph. So normally the parent function has a period of 2 pi. That is how long it takes to complete a cycle of secant. But if you have a B value, that will change. Okay, C represents a phase shift, so whether you are moving left or right. Since we are looking at the parent function right now, you can think of C being right in the middle. So let's say this value right here is C. And lastly is D. D controls vertical shift. So what D will do is change where this midline is. So I'm going to label that as D. Now all these same attributes apply to cosecant as well. So I'm going to try to go through those pretty quickly. So A measures how far away from the center we are, whether it is top or bottom. Period still takes 2 pi. The phase shift is still at the 0 mark for now, and D lets us know where the midline is at. Okay, we are going to graph these in just a second. So I wanted to tell you the difference between the period of each function. Secant, so let me zoom in here. Secant follows the pattern where it has 2 vertical asymptotes. Between those 2 asymptotes, it has its negative parabola, so the parabola that's pointing downwards. And on the outside of those vertical asymptotes, it has half of a positive parabola. So this, what I just drew, represents one cycle of secant, or in other words, it represents a period of secant. Okay, cosecant, on the other hand, not only begins and ends with a vertical asymptote, it also has a vertical asymptote right down the center. Between the first two, it has its positive parabola, and between the second two, it has its negative parabola. And again, what we just drew represents an entire period of cosecant. Okay, on this page, I also have listed the 4 different attributes that we are looking at. So vertical stretch is A, period is 2 pi over B, phase shift depends on what they are doing with C, so minus would go to the right, plus would go to the left, and vertical shift, minus goes down, plus goes up. So using all this information that we have gathered up here at the top of the page, we have 2 examples to work through. For this first example, we have the function f of x equals 2 secant of x plus pi minus 1. So what we want to do is identify the characteristics in order to graph this function. So each number in this function represents either a, b, c, or d. This 2 is a because it is at the very front. Pi is c because it's inside the parentheses. And negative 1 is our d. So using those numbers, we can get all of this information. So our vertical stretch is 2. That is our absolute value a. The period is always 2 pi divided by b. But you'll notice on this one, we didn't have a b value. So really it's an invisible 1, and when you perform that division, that is 2 pi. Phase shift, there is a pi there. And because it is plus pi, plus means that we are going to be shifting to the left. So pi units to the left. Vertical shift is 1. And because it's minus 1, that means that we are shifting down. So our midline is going to be at the line y equals negative 1. So using all of this information, let's draw some guidelines for us on the graph. So starting with midline, we're going to have a midline at y equals negative 1. So I am going to go ahead and draw myself a guide there. So hopefully you guys can see it's a very light green line there. And I'm just going to label it with an M for mid. So we got that down. The next thing is that the phase shift is we need to move pi units to the left. So starting at the 0 line always, and we're going to go the left direction, we want to go pi units. Good thing is that in this graph, it is labeled with pi. So this line right here is where our phase is going to start. It is where one cycle will start. So again, I'm just going to draw myself a guideline there. And I'm going to label it pi left, just so that I know why I wrote it there. Okay, for period, it needs to be 2 pi long. So starting from this green line that I did, we need to measure 2 pi. So this would be 1 pi, this would be 2 pi, right here. So that is where the period needs to end. Okay, and then I'm going to label it down at the bottom. Period equals 2 pi. Okay, and the last thing is that the vertical stretch is 2. So that means that starting from your midline, when we are drawing in our parabola shapes, they are going to touch points that are 2 units above the midline and 2 units below the midline. So the measurement from here to here is 2. Okay, so now that I have all these guidelines in place for me, I'm going to go ahead and try to draw this graph. Okay, so we are looking at a secant function. So I'm going to look at my parent function for secant to help me out here. So one period of secant should look like this. It begins and it ends touching that high point of the guidelines that we had. So back to this graph, you can tell that there's kind of a rectangle shape there. So according to that picture, it is touching the high point at both ends. Okay, let's take a look at the picture again. I also noticed that it has that low point right in the center. So right in the center, low. Okay, what else? So those vertical asymptotes are exactly in between those points. So it'd be that high point, asymptote, low point, asymptote, high point. So I'm going to draw in those asymptotes in between. So looking at my graph and the way I drew my dots, I have 1, 2, 3, 4 units in between. So exactly in the middle would be 2. So I'm going to draw my vertical asymptote right here. And same thing for the other side. Okay, now that I've drawn 2 asymptotes, I can tell that the pattern is every 4 squares. So I'm going to go ahead and fill in the rest of the graph. So I know I'm going to need that eventually. 1, 2, 3, 4. Okay, and now let's just fill this in. So this dot at the bottom lets me know that it's pointing negative. Okay, positive. Over here too, also positive. Okay, and then it looks like I can fit probably half of a parabola. So let's get that done. And then it would just keep going till you run out of space. Okay, so that is what this function looks like. 2 secant of x plus pi minus 1. So our minus 1 shows up in our midline. The plus pi shows up because we had to shift over to the left. And the 2 shows up because we are always 2 away from the midline. Okay, let's look at our next example. So this time we are going to be looking at a cosecant function. So this one is f of x equals 1/2 cosecant of 2x plus 1. So this one has 3 numbers that we're going to be looking at. The very first number, that 1/2, that is a. It is the first number right after the equal sign. The 2 is b, and the 1 is d. So notice that there is no parentheses. That's how I know that I don't have a c value. They would have to put parentheses if we are going to have a c. So now that I have those numbers, I can fill in my attributes. Okay, so starting with vertical stretch, it's going to be 1/2. Period is 2 pi divided by b. So 2 pi divided by 2 gives us pi. There is no phase shift because there is no c value. Our vertical shift is 1 up because it is a plus sign, so our midline is going to be at y equals 1. So now let's start drawing this stuff in. So starting with midline at +1, so I'm going to do myself a line there. I'm going to label it M for mid. Okay, phase shift, there is none, so I'm going to go ahead and check it off. But that just means that we're starting right at the middle. Period is pi, so starting from the middle, I'm going to measure out pi units, which is 4 squares. So that means that I need to complete an entire cycle of cosecant between these 2 lines. And last is vertical stretch is 1/2. So our points are only ever going to be 1/2 of a unit above the midline and 1/2 of a unit below the midline. Okay, now that I have enough guidelines, we can probably go ahead and start graphing this. So we are looking at cosecant this time. So as a reference, let's see what we had up here. So for cosecant, it has a vertical asymptote at the beginning, at the center, and at the very end of the period. So I'm going to draw those in for our graph. So beginning of the period, in the middle, and at the end. And since you can already tell that the pattern is every 2 squares has a vertical asymptote, I'm going to go ahead and draw those in as well. Okay, I'm going to go back to my reference to see what else we can do. Okay, so since I have my vertical asymptotes in now, the next thing I see is it has a positive parabola between the first two and a negative parabola between the second two. So on my graph, and I'm looking at this section here, I need to have a positive parabola, but it's going to hit a low point 1/2 of a unit above that midline. So I'm going to do my dot and parabola. Okay, now looking at this little area, it's going to be the opposite. It's going to be a parabola pointing down with a point 1/2 of a unit below that midline. Okay, so now I just need to keep repeating this pattern until I run out of space. So up, down. Okay, now let's work backwards. So as you can tell, I'm not being super precise, but I am trying to stay between the lines, try to keep it as neat as I can. Okay, and that is what this function would look like. 1/2 cosecant 2x plus 1. Okay, so there's our two graphs for secant and cosecant. Let me know if you have any questions.